So my topic tonight is science and religion dialogue from the present perspective. Sometimes science and religion dialogue, and sometimes science and religion conflicts. They were with us always from the very beginning. If we think about the very early Christianity, the advent of Christianity, then there was no science. There was pre-science, the Greek philosophy, and I think at that time there was the first ever conflict between pre-science and philosophy. Christianity had a message to convey to the humanity, and this message had to be formulated in a human language. But the language is human-made, and it had to convey a transcendent message, how to put into human words something which is by definition infinite. And I think this was the first ever conflict, an unavoidable conflict, which is always with us. And it cannot be smoothed out. We must just accept it, and without accepting it, we will have many other conflicts and pseudo-conflicts. So I will speak about science and religion dialogue from the present perspective. What does it mean from the present perspective? Everything we do is from the present perspective, but our everyday struggling with life is like climbing a mountain. And if we climb a mountain, we can only see our next step. We do not have any broader views. And this is why we must sometimes just pause, look backwards, and see the beautiful panorama, because otherwise we would not be able to evaluate what we have done. And this is what we will be doing tonight. I want just to pause now from the present perspective and give you a panorama of science-religion dialogue. It's not yet our journal. The travel journal is not finished, but nevertheless, from our present point of view, we want to look backward. I will not go to the beginning of Christianity. It would take us too long, but I will start at the end of the 19th century, and we will go back till the present time. Which was our heritage in the 19th century? In the 19th century, science was classical Newtonian science. And this science also had a certain philosophical implications. The main chapter of physics at that time was classical mechanics. And the view of the world made, basing on that classical mechanic, was a mechanistic philosophy. The universe looked like a mechanism. Sometimes some people regarded it as a clock. At that time, clock was the most advanced, most accurate instrument. Nowadays, we believe that perhaps the universe is a computer, because computer is the most advanced tool we have. So it was a mechanistic philosophy. This mechanistic philosophy gave rise to the current of philosophy, which is called positivism. The positivism was initiated in France by Auguste Comte, a French philosopher, in the 18th century and the first half of 19th century, and he claimed that everything before the advent of modern science, before Newton, was a negative knowledge. It is worthless, meaningless. The positive science begins with natural sciences, with empirical sciences, with Newton, and this is why this current is called positivism. Positivism claims that the only valuable kind of knowledge comes from the sciences. All philosophy, and of course all religion, should be abandoned. This mechanistic philosophy, with its positivist interpretation, was very common in the last decades of the 19th century. Nevertheless, new changes in physics were just behind the door. At the beginning of the 20th century, one of the greatest revolutions in human knowledge occurred. Revolution in the foundations of physics. In 1905, the special theory of relativity was created by Einstein. 10 years later, this theory of relativity was generalized, and Einstein formulated its general theory of relativity, which is a theory of gravity. 2 years later, he constructed the first cosmological model based on the general relativity. And starting from exactly 1900, quantum mechanics began to be formulated. Max Planck introduced the concept of quantum energy exactly in 1900. And the first 2 decades of the 20th century were an arena of young quantum mechanics. In the mid-20s, it acquired already some maturity. This was the great revolution in physics, because the old image of the world, Newtonian, mechanistic image of the world, was overthrown. So we meet the new image of the world at the turn of the centuries. And this was a great event in the human culture. No wonder that there were philosophers who tried to understand what has just happened. And this is a very, very rich period in philosophy, which struggled to understand what happened in the foundations of physics. Let's consider that a little bit further. I said that in the 19th century the world was mechanistic. This is 19th century. This is a mechanical machine. And this was the era of vapor machine, the trains and things like that. Also some beginnings of electricity. So this we can take as a symbol of the 19th century mechanistic philosophy. And new revolution in physics changed that entirely. Take, for instance, quantum mechanics. Quantum mechanics speaks about atoms, electrons, quarks, and other elementary building blocks of everything which exists. But we do not have access to atoms, to electrons, to quarks. Nobody saw a quark. We know about these entities only via equations. So mathematics became a kind of window through which we can grasp the inner structure of the universe. You see the big jump between the mechanistic, very easily to visualize image of the world, and something which is completely abstract, nevertheless very realistic, because all our technology, this microphone, our computers, everything works based on such equations. So there is a great urgent necessity to understand what happened. And there were philosophers who did that. A very eminent group of philosophers started to convene in Vienna, in Europe. They called themselves Vienna Circle, in German Wiener Kreis. They started to meet in 1907. So you see the beginning of the 20th century when this big revolution started. There are some names of this Vienna Circle philosopher, Frank, Hahn, Neurath. The most important figure was Moritz Schlick. He came to Vienna in 1922, and he organized a kind of seminars, and these seminars were called Vienna Circle. And the doctrine they created at that seminar was called logical positivism. Some people call that, especially in Europe, neo-positivism. And they claimed that the only valuable knowledge is based on experiments. So it was a continuation of 19th century positivism, but with a bit different shade of meaning. So only valuable way of knowledge is based on on empiricism, because they were completely lost in these new, experiments and results, and so they said all this abstract thinking is just a kind of scaffolding which, when the theory is ready, should be thrown away, and we should stick only what can be measured. And their doctrine can be summarized in the form of 3 reductionisms. The first is to reduce all sciences to physics. The physics, according to them, is the most basic science, and all other sciences like biology, psychology, sociology, all other sciences should be basically reduced to physics. This doctrine sometimes is called physicalism. And the second reductionism is that physics should be reduced to elementary sentences. And elementary sentences are utterances which give you, which register what you see during your experiment. So you see that an arrow on a gauge in your instrument coincides with the number 3, and this is exactly elementary sentence. And they believe that all physical theories can be reduced to the set of elementary sentences. If we use mathematical expressions and we say about laws of nature, it is just an abbreviation, because it would be very impractical to speak in terms of such elementary sentences. But nevertheless, the essence of physics, according to them, consists in that. And then the third reductionism, philosophy, should be reduced to the philosophy of science. All philosophy so far existing is meaningless. We should throw it away, and the only legitimate philosophy is rational reflection on science, and this is the philosophy of science. And perhaps the core of their philosophy was the new criterion of meaning. They identified the meaning of a concept with the possibility of checking that concept by experiment. If something cannot be verified or falsified by an experiment, it has no meaning. Philosophy cannot be checked by experiments or verified by experiment, therefore it is meaningless, it should be thrown away. Religion as well. You cannot verify theological statements in laboratory by experiment, so throw it away. Perhaps the most dramatic conflict between science and religion was exactly here. And Vienna Circle was extremely influential in the first half of the 20th century. Many people scientists, engineers, technical intelligentsia, they perhaps never heard about Vienna Circle, but the idea circulated in the air and everybody repeated them. And that time was perhaps the most difficult time for philosophy and theology. This is just a side remark. As you know, I spent a lot of my time under the communist regime, and of course I had to study the Marxist philosophy because I was objecting that philosophy, so I had to know what I am objecting. And this is a very strange affinity between, or relationship between the Marxist philosophy and neo-positivistic philosophy. Namely, the criterion of meaning, that everything which cannot be verified by experiment is meaningless, hits Marxist philosophy, because one of the main tenets of Marxist philosophy is that matter is eternal, and the matter is fundament of everything, is materialism. But you cannot verify in laboratory the statement that matter is eternal. So positivists in Vienna very often quoted Marxism as an example of meaningless philosophy. But nevertheless, Marxist philosophers assimilated anti-religious positive phraseology, but at the same time claimed that the only scientific philosophy is Marxism. So they took a propaganda tools from Marxism, from neo-positivism, but they claim against, of course, the fundamental assertion of positivists that the only scientific philosophy is Marxism. Well, so it was very difficult to be a believer scientist in the period of positivism, and after the Second World War, this still continued to be a period of positivism, and it was very difficult to be a scientist and a believer in that epoch. The only weapon of believers against positivist philosophy was the following. Let us assume that religion or theology or philosophy and the sciences are completely different. They do not intersect with each other. So we can use the following metaphor. We have two planes, Euclidean planes, for instance, and they are parallel and they never intersect. On the one plane there is a science, and on the other plane theology, religion, philosophy is situated. They never intersect. So even if we use the word creation, for instance, in the sciences, the particle is being created, or in theology, the term is the same, but the meaning is different. So there are not intersecting planes. Both theology and the sciences use different concepts, different cognitive tools. They are completely independent of each other. If there are some conflict, they consist in misunderstandings. So this was the main doctrine defending at that time religion from the sciences. That doctrine is very often repeated also nowadays in many circles. So this doctrine resulted in what could be called strict methodological separationism. They are completely separate. They use different methods, science and religion. This was based on sometimes very technical methodological distinctions between terms, tools, cognitive approaches, and so on. These methodological distinctions sometimes used very sophisticated logic and philosophy of science, and this was one of the merits of the Vienna Circle type philosophers, that they developed methodology of science. So it was certainly one of the merits. There were two distinct worlds, the world of science and the world of religion, as a consequence of that approach. And the first part of my life as a scientist I spent in these two schizophrenic worlds. When I was in my seminary, I was teaching in the seminary in Poland. I was in a different world. When I went to Krakow to the university to do some research, I was in a different world. And this is a story which illustrates that. Once we had a meeting with John Paul II at his summer residence in Castel Gandolfo, and he organized from time to time meeting with Polish philosophers and physicists, and we talked for 2 or 3 days about various topics. And I wanted to convey him a message that there are these two different worlds. There is not so much a conflict between science and philosophy, but there is a conflict between different worlds of science and different world of the church. I put a T-shirt. One of the astronomers in the Vatican Astronomy Observatory gave me his T-shirt. It was a beautiful blue, dark blue T-shirt with a Hertzsprung-Russell diagram here. Hertzsprung-Russell diagram is a very known to astronomers diagram which presents the evolution of stars. So I put that T-shirt, and on that T-shirt I put my Roman collar. So it was not visible. And I lectured before the Pope about cosmology, about Big Bang and evolution of stars, etc. very, very interesting, and he listened very carefully. And at the end, I wanted to say about the story about these two independent worlds. Say, when I go to from my seminary to Krakow laboratory, I must change. I must become another man. And I put my Roman collar, and I looked something like that. Yeah, this is exactly the Herschel-Russell diagram. But my diagram was a little bit different. This is, well, different picture. So this is to illustrate this artificial distinction between these two words. And quite unexpectedly, the logical positivism went away somewhere in the beginning of the 70s of the last century. Very, very suddenly. There were several reasons for that. One was that when Hitler came to power in the 30s of the previous century, Vienna philosophers escaped from Vienna to various universities, also to the United States, especially to the Chicago University. But nevertheless, this doctrine, which was focused on Vienna, now spread all over the world. So it ceased to be so radical, because they had to interact with various people with various views. This was one of the reasons why the positivism became weaker and weaker. But the main reason was development in physics. It turned out that physics cannot be translated into the set of elementary sentences. Physical theory is much, much richer than what we can verify in the laboratory. And this surplus consists in mathematical structure. Quantum theory, general relativity are very rich mathematical structure, and theoretical physicists explore that structure, and they tell experimentators what they should looking for, and they usually find that. So the progress in physics, so to speak, falsified the main assertion of positivistic history, positivistic philosophy. Another reason was the history of science. In the first half of the 20th century, the history of science was established as a new academic discipline. Before that, of course, there were historians of science, but they promulgated the image of the history of science distorted by the positivistic views. So everything before Newton, before Newton was bad, and everything after was good. And when at the beginning of the 20th century, people like, for instance, Pierre Duhem, a French physicist and historian of science, started to investigate documents, sources, old books, it turned out that it's not true, that in Middle Ages there was a very rich physics and astronomy, of course different, but very rich, and it was, in a sense, precondition for the future development. And then one of the Vienna positivists told later on in the 80s that we should in Vienna know the history of science, but we didn't. And this was our great drawback. And another reason for the overthrow of positivism was their own self-criticism. They were very critical people as far as other views were concerned, but they also were able to criticize themselves. Namely, they realized that positivistic philosophy cannot be verified empirically. Let's take the criterion of meaning. Everything which cannot be falsified or verified by experiment is meaningless. Can you verify that empirically? No, it's impossible. So they realized that it was a kind of vicious circle. And now logical positivists went to the history of philosophy. Of course, there are people who promulgate, the positivistic slogans, but on the top of philosophical, world, positive philosophy no longer is a leading one. So it's a marginal philosophy nowadays. We have now a post-positivist panorama in philosophy. Of course, there are many trends and currents in modern philosophy. I enumerate here only two of them, which perhaps are most prominent. There is an analytic philosophy, which more or less took the methodology, philosophy of science, they took from logical positivism, by developed that, but they reject, generally speaking, ideology promulgated by positivists. And analytic philosophy is fashionable, is developed mainly in English-speaking countries, and also in other countries as well, because, as you know, now English language is a very common language in science and in general culture as well. The other big branch of philosophy are various human-oriented philosophies. Philosophy of man, philosophy of culture, many other philosophies. And there is a not nice gap between these two worlds of analytic philosophy and human-oriented philosophies, which I think is not a nice thing in the present panorama of the philosophical world. Of course, all this had a great impact on the debate on science and religion. I will say about that impact in a moment, and now I want to say something about John Paul II's views on science and religion. I already mentioned that we had with him such seminars, but he had a genuine interest in the sciences. As a young priest, not yet a bishop, he liked doing ski, his photography here. And it just happened by chance that his companions in ski excursions in Tatra Mountains, not far from Krakow, were at that time young Polish physicists. And they started during these excursions discussing physics and philosophy. He was very interested in that. And then they continued these discussions in private houses. They visited once a month, sometimes more often, sometimes more seldom. They visited various people belonging to that group. Discussion continued. And when he became Bishop of Krakow, he organized, I already was part of that at that time, formal seminars in his residence, meetings between philosophers, scientists, and theologians. And this is why he developed a real interest in the sciences. When he became Pope, he continued that tradition of discussing philosophical and scientific matters, as I mentioned, during his vacations in Castel Gandolfo. So this is the origin of his interest in the sciences. At the beginning of his pontificate in 1979, there was anniversary of Einstein's birth, I think. At that time, some Italian physicists suggested to the Pope that Galileo should be retried and declared innocent. The Pope did not do that, but he did something, I think, much better. He ordered to establish a Galileo Commission, which should investigate from the scientific point of view, historical point of view, also theological point of view, the case of Galileo. And that commission, as far as I remember, worked 17 years and produced several big volumes studying the Galileo case, which is the best historians of science were engaged in that work. And I think it was a very good contribution to to the science-religion dialogue. In 1987, there was another jubilee, 300 years after publication of Newton's Principia. Newton's Principia is his most fundamental work, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy. This was the beginning of physics, and this date is considered, publication of Principia is considered to be the date, well, symbolically, but the date of the birth of modern physics. And in 1987, all the world celebrated that. And John Paul II asked astronomers in Castel Gandolfo to organize an event. But he said not to celebrate, just to celebrate the occasion, but to contribute something valuable to this science-religion dialogue. And at that time, the conference was organized, which now is denoted by this abbreviation PPT, Physics, Philosophy and Theology. Physics, Philosophy, Theology, PPT conference. At that conference, there was about 30 scientists from all over the world and some theologians and philosophers, as the title suggests. And they decided to have such meetings every 2 years in various places in the world, and to choose a concrete topic to be discussed during such a meeting. And there were 10 or 11 such meetings. Some were held in Castel Gandolfo, some in California, one was in Poland. And the topics which were discussed were quantum, the existence of the universe and laws of physics. There was biology and evolutionary theory. There was neuroscience, the concept of person, and things like that. It is 6 fat volumes after each conference, every volume more than 500 pages. And some of these volumes were reviewed by such journals like Nature, which never before happened that this journal would review such a book devoted to science and religion and dialogue. And these conferences, or PPT conferences, you can of course find all these things in the internet as well, at least some summaries of them. Very important document is a letter to Father Coyne. This was a letter written as an official church document by John Paul II to Coyne. Father Coyne was at that time director of the Vatican Observatory, and it was devoted to the dialogue, science and religion dialogue. Some people also, it was, if I remember, it was commented in such a specialistic journal, scientific journal like Classical and Quantum. No, it was not Classical and Quantum Gravity, but another one. I forgot the date for the moment. So it was rather unusual that a papal letter would be reviewed in the scientific journal. General relativity, gravitation. No, forget. 1996, there was a famous address of the Holy Father about the theory of evolution, and of course everybody knows the title of this encyclical letter, Fides et Ratio, Faith and Ratio. Nobody reads that encyclical letter, but the title is such a catching word and is repeated by everybody. Here I would like to read just one paragraph from the letter of, this is the official title, letter of His Holiness John Paul II to Reverend George Coyne, Societatis Jesu, director of the Vatican Observatory. This is just one paragraph, but it shows the deepness of that document. Some people say that it is the most important document anywhere issued by the Holy See, so on the science and religion dialogue. And the Holy Father says, if the cosmologies of the ancient Near Eastern world could be purified and assimilated into the first chapters of Genesis, might not contemporary cosmology have something to offer to our reflections upon creation? Does an evolution perspective bring any light to bear upon theological anthropology, the meaning of the human person as the imago Dei, image of God, the problem of Christology, and even upon the development of doctrine itself, that the doctrine can evolve? What, if any, are the eschatological implications of contemporary cosmology, especially in the light of the vast future of our universe? Can theological method fruitfully appropriate insights from scientific methodology and the philosophy of science? As you see, it's not only defending faith from some attacks coming from positivism or other atheists. It is much more. It is a demand or requirement to some new interpretation, new insights in theology coming from the sciences. And this work, as at the end of this letter, John Paul II writes, remains to be done. People often ask the question, will conflicts between science and religion continue to exist? My answer is yes, they will persist. And there are many reasons for that. Although science is neutral with respect to religion, it does not prove the religion, it does not contradict it, because, well, there are different methods and different concepts in science and religion, but there are various interpretations of science, and these interpretations can remain in conflict with religion. For instance, the positivistic interpretation of science was an example of such conflicting interpretations. Moreover, there are also various interpretations of religion, and between various interpretations there could be a conflict. This we have learned from the history. The history of conflict between science and theology is extremely rich, and I can tell that from my own experience, that if you want somebody ask you to explain a question, but not just in few words, but just in a more profound manner, if somebody is ready to spend a couple of hours to study the question, because only a very unimportant questions can be answered in 2 words. But if somebody is ready to do that in a more profound way, I always suggest to read something of the history of a given problem. And history usually explains at least 90% of the problem. Then methodological principles. Many methodological principles developed by positivists are correct, but they were over-interpreted. So we perhaps, the main starting point in responsibly doing with the science and religion is to begin with methodological principles, to use correct methodology. If we are approaching the problem without correct methodological principles, certainly we will contribute to greater misunderstandings, greater conflicts, and greater chaos. Of course, as science develops, the new challenges can be born. For instance, in my view, in next decades, the big issue between science and theology will come from neurosciences. The concept of soul, the concept of consciousness, and artificial intelligence, things like that. This, I think, is the possible reservoir of various conflicting issues, and I think we must be ready for that. We must have specialists in these fields from both sides in order to avoid these conflicts. And as I already mentioned, there are different mentalities of people, which is perhaps the most serious source of conflicts and most difficult to avoid. And now, how to be a believer scientist today? After the fall of positivism, the scene has changed, certainly. First of all, we can see a lot of mutual interests. Very often it happens that when there is a meeting of astronomers, scientists, or analytical philosophers, they invite somebody who could present a talk on science and religion, which was unthinkable some 20 years ago. So there is a mutual interest. This does not mean that the both sides know each other. I'm used to say that the ignorance of theologians, as far as sciences are concerned, is equal to the ignorance of theology as scientists are concerned. There is only one difference. If a theologian opens the book on general relativity, he immediately knows that he does not understand that. But when scientist opens, or does not open, but starts speaking about theology, he thinks that he knows everything. The positivistic doctrine about two non-intersecting planes is essentially true, because there are differences between science and theology, but these two planes, if you want to continue that metaphor, are embedded in the same space. So the space intervenes between them. And if we look at the history, so there was also always interaction between science and religion. And this space in which science and religion are embedded is just a common culture, which transfers interaction from one plane to another. Nowadays, as I mentioned, there are various symposia, societies, publications, organized almost every month. There are also international societies, very responsible ones, say European Society for the Study of Science and Religion. There are many in America. There is a sort of international academy, which is called International Society for Science and Religion. It has a rank of academy, and many others in which people meet and discuss such things. This is a new phenomenon and very promising one. This does not mean that positivist ideology is completely dead. It revives in various empirical philosophies. They don't call themselves positivists now, and they preach different slogans, but sometimes anti-religious propaganda is very, very similar. And what is very important in the present conditions is the necessity of bridge people, of people who would understand equally well both these different worlds. This is extremely difficult, because to be a good theologian and a good scientist requires the entire life for each of these disciplines, and one has only one. So this is really a difficult problem, and I must confess I solved that difficult problem, I think, in a very clever manner. Namely, when I am among physicists, I claim I'm the best theologian, and when I'm about theology, I'm the best physicist. And this works very well. What about limits of science? This is a nice picture, and I like to compare the process of development of science to that circle. The interior of that circle is what we do know now. There is a set of achievements, of scientific achievements. We know that. What is outside is yet unknown to us. And the circumference is where our knowledge borders with we don't know yet. And there are question marks, because we want to know, and we formulate questions here and address to what we do not know. What happens when our science progresses? Of course, the circle this becomes bigger and bigger. What does it mean? Our knowledge is, of course, increasing, but circumference is increasing as well. So we have more and more questions. And this is really true as far as history of science is concerned. The history teaches us that one problem solved generates perhaps 10 more difficult problems, or even more. So this is a good thing, because scientists will never be unemployed. This picture represents limits of science, of scientific achievements. So the limits are pushed further on and further on by the progress of science. And now, more important problem. Well, perhaps no. Let's skip that. Limits of scientific method, not of science, of method itself. So my question now is: are there some questions which cannot be solved by the empirical method? Never. There is a very good principle in the as far as science is concerned: never say never. But nevertheless, well, I try to formulate 3 questions which probably will never be solved by scientific method. The first is a ontological question. Why is there something rather than nothing? This question in such a form was formulated by famous philosopher Leibniz, Gottfried Wilhelm Leibniz. This is a dramatic question. Why is there something rather than nothing? Science cannot answer that, because let us imagine that scientists one day will explain the creation of the universe. Let's imagine that. In fact, we have some working models called the quantum creation of the universe. But scientists must start with physical laws. So they must presuppose something. It is not nothing, but they must start at least with physical laws. Without them, they cannot do nothing. Therefore, the crucial problem is where the physical laws come from. Why there is something rather than nothing. If there were nothing, there would have been no problems at all. It was the simplest thing we can imagine. But nevertheless, the universe exists with a complicated structure, with a lot of physical laws, which probably we will never, never will be able to know all of them. And another question is an epistemological question. Namely, the basic principle in science and philosophy, in everything, is that our knowledge must be rational. That means that we should attempt to argue for our convictions, not assume them just from the air, but argue in behalf of them. Argue in behalf of them. But how to argue on behalf of the fact that our views must be argued for? If you try doing that, you presuppose what you want to show. So the only solution of that, and it was famous philosopher Karl Popper who suggested such a solution, that if we decide to be rational, it is a choice. The choice between irrationality and rationality. And since rationality is a value and irrationality is a negative value, this is a moral choice, because it is choice of a value. And all our science, all our philosophy is based on that choice. And science cannot prove that. Science is built upon that. And there is also another, the so-called axiological question. Axiology is the science of values. Of course, what is bad, what is wrong, what is good. Science cannot answer to that question. It is also the problem which goes beyond the limits of scientific method. Well, and this slide summarizes what I said and what I have had to say, but have no possibility. And so the science gives us knowledge, and the religion gives us meaning. And without meaning, without religion, even science would be meaningless.